Friends, in this video we are going to learn about the concept of inequalities. So this is a model question of inequalities. There will be a direction given followed by a statement and a conclusion, and we need to find which conclusion follows or not. The important thing in this direction is what he is asking, right? Here they are asking which conclusions are definitely true. For suppose if we see the conclusion 1, E greater than T, the relationship between E and D cannot be determined, so it is wrong. He is also saying A is equals to X, A is here, X is here, so A is less than X, but given A is equals to X, so this is also wrong. So what he is asking, which is definitely true, right? But both are wrong. In this case, the answer would be neither 1 nor 2 follows. But if suppose in the direction, if he has asked us which are definitely false, then the answer would be both 1 and 2 follows. So this is going to be very important to find the answer. Now let us see how did I solve this by understanding the concept. So in inequalities, only there are 3 comparative signs. Basic comparison signs are only 3. For suppose if they are given any 2 elements, for suppose A and B are 2 elements, the relation as per inequalities can be either greater than or equals to or less than. Only 3 relations are going to be established between 2 different elements. So the basic comparisons are 3: greater than, equals to, less than. And we can also get combination signs, that is by combining greater than and equals to we get greater than equals to. Similarly, by combining equals to and less than we get less than equals to, and by combining these greater than and less than we get greater than or less than. There are also negative signs, which means not greater than, which means other than greater than we need to take remaining 2 basic comparisons, which means not greater than is nothing but less than equals to, not equals to is nothing but greater than less than, not less than is nothing but greater than equals to. Similarly, we can solve for remaining. Okay, only these 3 basic comparison signs, and these all the other are derived from these 3. Okay, for solving the problems of inequalities, we need to understand the priority of symbols, right? The priority of symbols can be found only for single facing signs, which means we can only find comparison between greater than, equals to, and equals to, as they are facing to one side. We cannot find a relation or priority between opposite facing signs. So for same sided comparison signs, the priority is as follows. The first priority would be given for greater than, second priority would be for greater than equals to, and third priority would be for equals to. Similarly, for the other opposite side facing comparisons, the first comparison will be for given for less than, second for your less than equals to, and third for equals to. So let us understand this with an example. I shall take a statement A greater than B greater than equals to C is equals to D less than E less than equals to F is equals to G. So if you want to find the relation between A and D, A is here, D is here. What are the signs between them? Greater than, equals to, and equals to. So all are single sided facing. There are no opposite facing members. So we can determine the relation between these two. As per the priority of symbols, which I already explained here, the first priority would be given for greater than. So the answer would be greater than, A greater than D. Similarly, we can find the relation for A, C, B, D, D, G, E, G, and D, F. Okay, let us find these relations as well. So A, C, he is asking relation between A and C. A is here, C is here. What are the signs between them? Greater than, equals to. As per the priority of symbols, we can say that A is greater than C because the first priority would be for this. Similarly, for B and D, B is here, D is here. What are the signs between them? Greater than, equals to, and equals to. So when these two are given, the priority would be given for greater than, equals to. Similarly, for D, G, D is here, G is here. What are the signs between them? Less than, equals to, and equals to, right? So for these 3, the priority would be all are single sided facing signs. So D is less than G. For E and G, what are the signs between them? Less than, equals to, and equals to. What is, as per the priority of symbols, between less than, equals to, and equals to, the first priority would be given to less than, equals to. So the answer would be less than, equals to. Similarly, for D and F, D is here, F is here. what are the signs between them? Less than, equals to. As per the priority, when there is less than and less than equals to, the first priority would be for this. So the answer would be D less than F. For suppose if they are asking the relation between A and G for the same statement, if they are asking the relation between A and G, where is we need to find the position of the elements. A is here, okay, G is at end. What are the signs between them? Greater than, equals to, less than, equals to. So there are opposite sided facing numbers, right? We are getting greater than, less than, equals to. As I already said while explaining the priority of symbols, when there are opposite sided facing numbers, then the relation between two elements cannot be determined, right? What I mean by cannot be determined, it means that A can be either greater than G, A can be equal to G, A can also be less than G. Let us understand this cannot be determined with an example. Let us take a statement A greater than B, less than C. So this is a small statement. Now you need to find the relation between A and C. As already discussed, we can say directly that as there are two opposite sided facing numbers, the relation is cannot be determined, which means A should be greater than, A can be less than, A can be equals to. So don't confuse with this sign. This sign is nothing but it can be either greater than, it can be also equals to, and it can also be less than. So when the three signs are combined together, we get this combination sign. Just for your understanding, okay? So now what we shall do is we should substitute some elements which satisfy the statement. I shall take A value as 5, which is greater than B value as 4, is less than C value as 6. So these values are satisfying the given statement, right? So from these values, we can say that 5 is less than 6, which indeed means that A is less than C. See, you are getting one possibility, right? Similarly, we shall take 5 is greater than 4 is less than 5. So by seeing this, you can also say that 5 is equals to 5, which indeed means that A is equals to C, right? We are getting second possibility. For suppose what we shall do is we shall take 7 is greater than 4 is less than 5. So we get that 7 is greater than 5, right? Which indeed means A is greater than C, which is third possibility. So this is just for your understanding. Why does cannot be determined gives three possibilities. This is an example, right? If you don't want to, if you didn't understand this, not an issue. The priority of symbols can be determined only when single sided facing numbers are there. When they are asking priority between two opposite sided numbers, the answer is cannot be determined. And cannot be determined indeed means it can be greater than, it can be equals to, it can be less than. Three signs are possible. So if you understand this concept, we can solve this problem. Now let us see a statement. A statement P greater than Q, some statement is given. In conclusion 1, they are saying S is less than P. So what are the two elements as per the conclusion? S and P. First we need to point out, find where the elements are. P is here, okay. S is here, okay, nice. So what are the comparative signs between them? So there is greater than again repeated, okay, greater than equals to. So there are only two signs between them, which is greater than equals to. So same sided comparison sign. So we can, as per the priority, we can determine the relation between them. So what can we say as per the priority symbol? This would be a first priority and this is second priority. So we can say that P is greater than S, right? It can also be written as P greater than S is nothing but S less than P. So we get this from the given statement. So the conclusion is true. Now what the second conclusion is stating? Q is greater than equals to T. First we need to find Q. Q is here. Where is T? T is here. Okay. So again the comparison signs between them are greater than equals to, and greater than equals to. So as per the priority, this would be a first priority, this would be a second priority. So the relation between Q and T is, as per the statement, Q is greater than T. But here they had given Q is greater than T, but they are also saying Q is equals to T. So Q greater than T, if they had given only Q greater than T, this would have been correct. But they had given is equals to T, which is impossible because we derived from the statement only Q should be greater than T. So this is wrong. So we shall tick only one follows would be your answer. This would be your answer if and only if in the direction, as I discussed earlier, if they are asking which is definitely true. If suppose they had asked in the direction which is definitely false, then the answer would have been only 2. Okay, keep this in mind. Now let us, we can solve these conclusions as well. Now let us understand a shortcut method, right? There is a shortcut method of solving these inequalities. So there are 3 comparative signs: greater than, equals to, less than, right? Greater than, we need to understand that it is we need to imagine this as a gate and this is as an opening. So one person can move inside and this is an exit, which means that for greater than symbol, one can move towards this side, one cannot move from here because this is gate opening, one can enter from here. For is equals to, we can move from this side, we can enter from this side as well. For less than symbol, one can only enter from this side, one cannot enter from this side. This you need to by heart, like you need to remember it, that for this is gate opening, only one can move from this side, one can move from this side. Now let us apply this in the next question, right? The same question which I had already discussed earlier is given here. The same statement is given here. Let us solve the same conclusion which I had already solved earlier. So what the conclusion is saying, S is less than P. As per the shortcut method, what does it mean is, from P we need to move to S, right? Because as the opening is here, from P we need to move to S. We need to see where is P, where is S. P is here, S is here. From P we need to move to S. If it moves, then it is correct. If it does not move, it is wrong. Okay, that is a basic rule here. From P we can move to Q. Okay, as from P we can move this direction. From Q again we can move this direction. From R we can move towards S. So from P we can move to S. So this is true. Okay, that is as simple as that. From Q, as per second conclusion, from Q we need to move to T. Where is Q? Q is here. Where is T? T is here. From Q we can move to R, from R we can move to S, from S we can move to T. From Q we need to move to T. As per in the path between Q and T we are able to do, but we should not tick it as correct. This is wrong. Why? There is also one more thing to remember in this is, whenever there is equals to sign given. So when Q is moving to T, towards T, in the entire path they should have is equals to. Right, which means that if is equals to has been given here, if is equals to they are given here, then the entire path would have been is equals to, right? Then only it is true. As is equals to is not given here, in the statement they are mentioning only Q greater than R. Hence, this is wrong. The simple thing is, if it is greater than symbol, we can move from left to right. If it is less than symbol, then we can move from here to here, as per gate opening concept. From is equals to, we can move from both sides. And also whenever there is equals to in the path, the entire path should have is equals to. Okay, if you understand this, let us solve this remaining. As per the conclusion, from P we need to move to Z. P is here, from P we need to move to Z. So P is here, Z is here. So from P we can move to Q, from Q to R, R to S. There is no is equals to. So in the path, if there is no is equals to once, so there is no is equals to here. So we can continue S to T. So not less than is nothing but greater than equals to. Let us convert all these signs. Okay. From T we can move to U, from U to V, V to W. From W we cannot move to S, which means that from P we can move till W. We cannot move further. So this is wrong. Okay. Similarly, from Q we need to move to Y, and the entire path should have is equals to. So Q is here, Y is here. So simply we can see that there are opposite signs. So from here we cannot move here. So this is going to be wrong. Okay. See, from Q we can move to R, but there is no is equals to. Simply we can reject here, straight off. Okay. Conclusion 3. From P we need to move to U. Where is P? P is here, U is here. Okay. Only moving, there should not be is equals to. Okay. P to Q we can move, Q to R, R to S, S to T, T to U. We can able to move from P to U. So this is true. Second conclusion, from Q we need to move to W. Q is here, W is here. There is no is equals to here. So Q is greater than R. From Q we can move to R. No is equals to. So we can continue R to S, S to T, T to U, U to V, V to W. So from Q we can move to W. Here neither 1 or 2 follows. Okay. Here both follows. Okay. For conclusion 4. they are saying that z is greater than x, right? Which means that from z we should move to x. Where is z? Z is here, x is here. From z we can move to y. So there is no is equals to here. Okay, keep this in mind. Z to y, y to a to x. Right? This is true. From a we need to move to v. A is here, b is here. A to v. We can move from a to x, x to w, w to b. But when you see this in the entire path, there is equals to, which means that a is greater than equals to v. But here they are given only a is greater than v. So this is wrong. The answer would be only 1 follows. So for conclusion 5, p not less than equals to t means p greater than t. Convert this to normal sign, which means that from p we need to move to t. P is here, t is here. P is greater than q, we can move q to r, r to s, s to t. There is no is equals to given, so this is true. W is not greater than equals to means less than. From z we need to move to w. So where is z? Z is here, w is here, right? No is equals to z to y, no is equals to z to y, y to a to x, x to w. We can move, so this is true. Both follows, okay? Similarly, s is not less than v, which means that s is greater than equals to v. Equals to should be in the entire path while s is moving towards v. So s is here, v is here, s to t we have is equals to t to u, we have is equals to u to v, we have is equals to. So s is greater than equals to v is true. T is not equals to x, which means that not equals to is either greater than or less than. So this is t to x we should move, we can move to x to t, which is impossible. So we shall generally check it. Okay, t is here, x is here, right? T to u, u to v, v to w, w to x, we cannot move. So if you remember the previously normal general method, by seeing the comparison signs, we can say that the relation between t and x is cannot be determined, which means that t can be greater than equals to less than, but only they are given greater than less than, so this is going to be wrong. The answer would be only 1 follows. Now let us see a case of either or, where generally mistakes do happen in inequalities. Okay, either or. Now let us understand, I shall say small concept here. If you watch cricket, generally before start of the match we throw a toss, right? Toss happens. Either the result of the toss would be either heads or tails, right? Which means that when someone throws a toss, if it is heads, there won't be tails. If it is not heads, then there would be tails. Ignore the hypothetical situation where the coin stands here. Ignore this, okay? We are not going to discuss it. Which means that either or is nothing but if one is right, the other should be wrong. The other is wrong, the first one should be correct. Which means that two rights cannot be possible, two wrongs cannot be possible. Okay, this is just for your understanding. What I mean by this two rights is cannot possible means it cannot be heads and tails at the same time, or the answer output won't be neither heads nor tails, right? When you throw a toss, it would definitely be heads, either heads or tails. Okay, this is nothing but either or. Okay, if you don't understand this also, just ignore it. But now I shall explain it with the help of examples. So given a statement, there is a conclusion here. B, D. B, from B we need to move to D. B is here, D is here. From B we can move to D, but as per the priority we can understand that B is greater than equals to D. So B is equals to D is given, it is wrong. B is greater than D. From B we need to move to D, right? From B we are able to move to D, but B is greater than or equals to. But here given only B greater than D. But when you combine these both, we get B is greater than equals to D, right? We are getting the required answer. So the answer would be either 1 or 2. Either 1 or 2 follows. Okay. See, I shall explain it again. The relation between B and D is B is greater than or equals to D. In the conclusion they had given B is equals to D, which is wrong. Individually, right? B is equals to D might not be the case. If you are saying B is equals to D, then there is also a possibility of B greater than D. In the second conclusion, they had given B greater than D. When we combine these both, we get B greater than or equals to D, right? So the answer would be either 1 or 2. Now let us see for other examples. They're asking relation between E and H. From E we need to move to H. E is here, H is here. From E we can move to F, F to G, from G we cannot move further. So the relationship between E and H is cannot be determined. Here they are given E is greater than H, which is wrong. Here they are given from H we need to move to E, from H we can move to G, G to F, from E, F to E we cannot move. So this is also wrong. But when you see here, E and H, there are common elements, and the relation between E and H is cannot be determined. It means that E can be either greater than, equals to, or less than. So these three symbols should be there. E is greater than H, we have. E is less than H, we have. E is equals to H, we have. So the answer would be either 1 or 2. Right? So the relation between E and H is E is greater than H is possible, E is equals to H is possible, E is less than H is possible. If you take individually, we don't get the correct answer. But when we combine these both, E is greater than H satisfies, E less than H satisfies, E equals to H satisfies. So the answer is either or. Now let us see for conclusion 3. They are asking relation between A and H. A is here, H is here. So they are saying from A we need to move to H, A to B, B to C, C to D, D to E, E to F, F to G, but we cannot move further. And also we can understand that the relation between A and H is cannot be determined. This is wrong. From A again we need to move to H, we have is equals to, we have already seen that A is unable to move to H. This is wrong. But when we combine these both, are we getting these three signs? Though by just seeing it, we are getting three signs, but when we reframe it, A is greater than or equals to H, we are not getting A less than H, right? What we are getting as per the conclusion is A is greater than H, A is greater than or equals to H. But the relation between A and H is cannot be determined, which means that we need to have A greater than H, A is equals to H, and A less than H, right? So, but we are only getting greater than and equals to, so the answer would be neither nor. We also need to see the position of elements given. We should not only blindly see the signs. Here it is greater, less than, equals to, so I will be ticking either or. No, we need to see the position of elements as well. Okay. Now in the conclusion 4, we need to see from A we need to move to D, right? A is here, D is here. From A we can move to B, from B to C, C to D. So there is no is equals to here, no is equals to, this is right. From A to D we can, though we can move, there is no is equals to everywhere, so this is wrong. So from this example, what we can conclude is just by seeing both elements are same, there would be either or case. That's not a possible answer. Okay, just blindly seeing both conclusions have same elements, so that will be ticking either or, then you would be losing your marks. For this, the answer is only one follows. Okay. Now for conclusion 5, from E we need to move to H. E is here, H is here. From E we can move to F, F to G, but from G we cannot move further. So the relation between E and H is cannot be determined. So cannot be determined means, as already discussed, it can be greater than, less than, equals to. So this is wrong individually and this is also wrong individually, but when you see, when you rephrase it, E is less than or equals to H, the second conclusion, we are getting three signs. So then the answer is either 1 or 2. Now let us see for conclusion 6. From B we need to move to E. B is here, E is here, B to C, C to D, D to E. While moving we are having is equals to, so the answer is B greater than or equals to E, but here given B is greater than E, which is wrong. B is greater than or equals to E, so it is true. So the answer here is only 2 follows, right? This is also an important example. Just blindly seeing these two elements are same and they are having three relations, so I will be just ticking directly either or. That's not the case. We need to find the relation and we need to check whether there is a case of either or not, then only conclude it. So here I is equals to K is not equals to means greater than or less than. So from K we need to move to I, or I to K. First point out where is I, where is K. So between them there are two opposite signs. The relation between I and K is cannot be determined, which means we should have three signs. We have is equals to as per first conclusion, we have greater than and less than as per second conclusion. So though both individually are wrong, the answer is either 1 or 2. Now let us check for conclusion 8. E is not greater than I. So which means that E less than or equals to I. So we need to find relation between I and E. E is here, I is here. From E to F we can move, F to G, G to H. So we cannot move. There are two opposite signs. The relation between E and I is again cannot be determined, and we need to have these three signs. So though individually they are wrong, and also the answer won't be either or. The answer is neither nor. Why? This is very important. Kindly listen to it. So though they are having three signs, we are having is equals to in both the conclusion, which means that if there is a case like as discussed with numbers, E can be greater than I, E can be equals to I, E can be less than I. There are three possibilities. If this is a possibility, then these both are correct, right? Because they both have is equals to signs, right? So as both are right, then either or case won't satisfy. As I already discussed, there cannot be heads and tails at the same time. So the answer is neither nor. If you didn't understand anything whatever I said till now for either or case, you need to see that first you need to establish the relation. Okay, whatever is here, you need to establish the relation and see whatever the relation is there. The relation should come only once. They should not repeat. In case if there is repetition, then it is not a case of either or, right? What we did here, we established the relation between E and I. Excuse me. We had established a relation between E and I. What is the relation? It is cannot be determined, which means that E can be greater than I, E can be equals to I, E can be less than I. So though, and the first statement follows. What I had said in the second statement, the relation should come only once, they should not repeat. Here is equals to is repeating, so this doesn't satisfy, hence it would be neither nor. Similarly for conclusion 9, they are asking relation between A and L. A is here, L is here. There are opposite signs between them obviously, so the relation is cannot be determined. Though we have three signs, is equals to is repeating again, so it would be neither nor. For D and F, E and G. So from D we need to move to F, from E we need to move to G, or F to D, anything. D is here, F is here. So by seeing this, we can say that D is greater than or equals to F. This is wrong. E is here, G is here. By seeing that, we can say that E is greater than or equals to G. This is also wrong. So this is important here. The answer is either or, either one or two. Why? Though the elements are different, from the statement we can say that D is nothing but E, right? They said D is equals to E. F is nothing but G. They said F is equals to G. So F is G. So conclusion 1 can be transformed to D is equals to F can be transformed to E is equals to G. So what he is saying, E is equals to G, E greater than G. What we found from the relation, E is greater than or equals to G. The signs are only one time, they are not repeating. E is greater than G, E is equals to G, hence either or case. So from this what we can conclude is just by seeing the elements are same, then only either or case won't happen. If they are given is equals to in the statement, we also need to look into that. Okay. For conclusion 11, this is also very important. See, understand. So from G we need to move to M, from M we need to move to G. So where is G? G is here. Where is M? A, B, C, D, E, F, G, H, I, J, K, L. There is no M in the statement. So when there is no M in the statement, the relation between G and M cannot be determined. Right? Cannot be determined in the sense G can be greater than M, G can be equals to M, and G can be less than M. So these three signs should come. G is greater than M, individually it is wrong. G is less than or equals to M, individually it is wrong. But when we combine these both, we are getting the three signs and no sign is repeating, hence it is an either or case. Either